Good to go. Hi, welcome to our R&D showroom in our factory in Poland. And my name is Paul. I'm going to talk you through one of our newest products, which is the HexWall system. So some of you may have already had emails from me or the rest of our team across the world, really sort of opening up the discussions for this new product. What I'd like to try and do today is to try and give you a little bit more of an in-depth look about this product and why we think this is so good and such a disruptive change for our industry. So, what I'd like to start with first of all is an overview of what our HexWall system is and what it can do for you. So as you can see on the screen, the new HexWall system is really about increasing the amount of airflow that we can get through a counterflow heat exchanger. Counterflow heat exchangers have been around for a long time, but they've always been limited to the amount of airflow that you could realistically get through one. So what we'd like to try and do with our new HexWall product is to really increase the amount of airflow that's possible through a counterflow heat exchanger, whilst retaining the benefits of a quite good pressure drop, whilst having a very good high level of thermal efficiency. So the Crossflow heat exchanger now, with this new HexWall, is optimized to work within large ventilation systems, whilst retaining those high levels of efficiency and pressure drop. So to look at a more overview of the actual unit itself, contained within this case are multiple pieces of counterflow heat exchangers. And the idea of this was that we would contain all of these in one case so that you would be able to just slide the whole unit into your air handling unit and without any fuss or any labor issues on the shop floor at that particular time. So with this unique casing design, what we actually do is these apertures here allow for the division of airflow within the case so that we can make sure that we keep both the supply and the exhaust airflows separate, whilst also directing the airflow across the whole face of the heat exchanger that's in there. So this is why you have these sloped channels that show on the side there. But what we can also do with this particular model here is that this is a model that has a top bypass system. So our core competence is always going to be the heat exchanger itself. In terms of the bypass section, what we do is we create the unit so that it's very easy for you to apply your own thermal bypass system. On this particular unit here, you would see that in an environment where you wanted to optimize the bypass as much as possible, you would simply fit some dampers on the face of the unit here. You can see at the top of the unit, we actually have a good amount of space where you could fix some dampers too. And what would happen is that the air would flow over the top of the unit and then down through two holes that we have here on this side. Obviously, the bigger the unit that we have, the more holes we would have in there for the air to bypass. And then at that point, what it does is it then goes down towards the bottom and out onto the bottom deck of the supply at that particular point. So how does it work? It works by combining multiple counterflow heat exchangers into one case, whilst also trying to retain a level of normality within an air handling unit so that the air would enter on the top deck and cross decks and exit on the lower deck at that point. So in terms of working from a crossflow heat exchanger into a new type of HexWall unit, actually there's not much difference in terms of the physics and the size and the way this is put together. So simply the air would enter on the top, it would go through the heat exchanger and exit at the bottom on the opposite side. Now, one of the benefits you get with a counterflow heat exchanger is that when we compare it to a crossflow heat exchanger, the dwell time is significantly increased within a counterflow heat exchanger. So obviously, the longer the amount of time that the air spends inside the heat exchanger, the higher the level of thermal efficiency that we can create from there. And obviously, from the backside of that, the higher the air off temperature in the winter months. With a larger face and plate area of the counterflow heat exchanger combined into a HexWall, we can really deliver this higher volume of energy recovery that you would expect to receive from a crossflow unit in perhaps a smaller style of unit. So, when we go to some of the advantages, we do this in a large range of sizes. But the main criteria is to have it so that we can just slide it into the AHU, simply make the condensate connections that would be contained within your condensate tray, and then you're good to go. Very soon, within the next 2 weeks, so I'm reliably informed, we're going to have a selection software that will be completely online, also available in a DLL format so that you can drop it into any existing systems, and you'll be able to make selections on this by yourself. However, in that time, we can still make selections for you on this. So if you do have any requirements, feel free to send them across either via the YouTube channel or via the website, or to me directly, or to any of our key account managers across the world. When we're looking at the advantages when it comes to energy recovery on this, the most important thing we have to remember with any kind of air handling unit is that we need to be sticking to the legislation and the guidelines. So for our industry now, we're focusing towards ERP 2018, which is a minimum of 73% efficiency. But we also need to do that whilst maintaining a low pressure drop in order to keep the unit very competitive. So by maintaining this low level of pressure drop, we can keep the specific fan power low for the air handling unit whilst also getting the bonuses for having a very high level of efficiency. But one of the most important things recently that I've had from a lot of discussions that I've had across Europe and other parts of the world is that the fear of coronavirus and the coronavirus pandemic and leakage. This is as close to COVID-19 ready as we're going to get from a plate heat exchanger. With the sonic welding that we use on a plastic type heat exchanger that's within this unit, we can get very close to a 0% EATR cross-contamination rate. And that's extremely important these days in specifications for customers. So we're aware of that, and this is really one of the lowest levels of cross-contamination that you can get on the market. But afterwards, there's also, once this is sold and it's installed in your customer's project, there is no maintenance with this. So no belts to change, no seals, no motors, nothing to change. It's really exactly just a fit and forget product. So when we look across the sizes that we have available for this type of product, you can see that we have 17 different sizes. Now, the way that our business model works is that we try to make things into certain sizes so that we can build them very quickly, keep everything to a cost, and get them out to our customers as fast as possible. So when we look at the sizes that are on the screen right now, you'll see that we start with a size 600 and we go all the way through to a size 2400. Now, in that column, you'll also see a nominal airflow that we think is a fair level of airflow versus efficiency versus pressure drop that you could expect to achieve with one of these units. And as you can see, when we start to get past the HW1400, we're in new territory for counterflow heat exchangers. Usually it wouldn't be possible to get a counterflow heat exchanger to that level of efficiency. So we're really breaking the markets here now with this type of new heat exchanger technology that you can see in front of us. One of the interesting parts is that we also have two different configurations that you would see this in. So we have one where there is a side bypass, which is very similar to the size, shape of the unit that you would see on the screen right now, or then we have this type of unit which is based with a top bypass. Now, we do have more of the sizes of units with a top bypass than we do with a side bypass. Actually, when I've been discussing this with customers, this is the preferred method. The top bypass is the preferred method because it's a very neat solution for our customers. One of the things that's always important, and for me, I feel that this is one of the smoking bullets that we should always expect to try and get, is whenever we build a specification, we should try to make our specification as unique and as solid as we possibly can. So when we look at the typical type of a project, they rely very heavily on engineering-based specifications. That really, as a model for our industry, really drives the way that we raise the standards in the world. But not all specifications are built equally. So there's often very simple changes and things that happen throughout the process of specification from consultant to contractor to end client that can change things. But there are a number of criteria that can really solidify and really cement our chances of holding that specification with both the consulting engineer, the contractor, and ultimately the end client. And those things are based around physical size. So if something's too big, it's too big. It's not going to go where you need it to go. So if something is much smaller, the chance of either breaking somebody else's specification where there is a large unit, or maybe holding a specification because a competitor's unit couldn't fit within the same space, that will be a good thing to hold the specification by. Thermal efficiency. So if we are just about struggling to hit 73% efficiency with a cross-flow heat exchanger, with a HexWall, we know that we can beat a level of efficiency that you would expect from a cross-flow heat exchanger. So again, that's a very specifiable point. If the consulting engineer was to specify, must be no lower than 78% efficiency, then we know that with HexWall we can beat that. Specific fan power. So that's another important part. So keeping the pressure drop as low as possible for our customers' units is very important. So we need to make sure that we have a very optimized design that lowers the amount of additional pressure drop that we put by separating airflows through the case. Unique features, so something like the top bypass, or something like the size and the shape of this, or the fact that it's no maintenance, that's a unique feature, and again, specifiable. Leakage, obviously, by using a sonic welded composite plate heat exchanger type like we have here, the leakage is very, very low. So that's, again, something that we could hold a tight specification with. Material properties. So it's the casing, the type of heat exchanger that's in there, everything else that's connected to the materials that you would expect to have. Now, we are aware of this, and I have actually had the pleasure of working in a job of getting units specified with contractors and consultants and holding those specifications. So I know just how hard it can be to get a very tight specification on a product. But one of the most important things that we need to understand is that to hold a very tight specification, we need to try and have some unique features that make it difficult for somebody to break a specification with. But one of the more important points that we didn't cover in the last slide is cost. You can have as many unique specifications as you like, but if the cost is 10 times higher than the competitor, the chances of that specification holding are very slim. So we build HexWall with cost in mind, and that's why when we get onto the later slides, you'll see that there's a very good cost saving to be had from using a HexWall versus a Crossflow. So some may say this could be the death of Crossflow. Is it the death of Crossflow? I believe it's the early death of Crossflow, yes. So Crossflow is an old technology. It's been around for a long time, and it's a tried and tested technology. And I don't hate Crossflow. I think it's a good technology, but I think it's had its day now. They're often very costly, Crossflow units, because they're very heavy, they're very big, and they're often made from aluminium material only as well. So they're often very costly. They're very good for high airflows though, because you can moderate the plate spacing that you would get between each layer. They offer a very low leakage, the same as we do with a HexWall, but they do struggle today's world with 73%. You do have to make them quite big, and whenever you make something quite big, you also make it quite expensive. And it's a commodity item. Everybody has a Crossflow heat exchanger in our industry, so really making a tight specification with a Crossflow is going to be very tough. Then there's the newer type of combi counterflows that you get, which is a recent technology, but it has a complex factory build, so you have to assemble those separate components together when they arrive in the factory. And I know that from a labor perspective, that can be restrictive, so it takes a lot longer to assemble these types of products together. They're good for high airflow, similar to the HexWall, and they also possess a very low leakage as well, the same as the HexWall. They have a great level of efficiency with a combi counterflow, and they can create a good spec, but it's not unbeatable. With the HexWall though, it's different. So this is a brand new patented technology that we have within Swiss Rotors right now, And we're showing it to you guys here for the second time, I think now, after my colleague Lex first webinar that he gave. But one of the big advantages we have here against a counterflow combination is it's a rapid and simple factory build. So what you see in front of you is what arrives. You just slide it into the unit, make the condensate connections, and you're good to go. These are very good for high airflow. So with this type of unit, it's not impossible to get up to 27,000 meters cubed an hour out of one of these units as it stands right now. But they're also modular, which we'll cover a little bit later. Very low leakage thanks to the sonic welding of the high efficiency composite plate heat exchanger, and they have a very high efficiency. Typically on the model that you see in front of us, you wouldn't see anything less than about 78% efficiency. That creates an unbeatable specification on size versus price versus efficiency. So what we'll do now is that we'll have a look across some cherry-picked sizes and compare how those stack up against a cross-flow type heat exchanger, the older style technology. So if we look on the screen here, you can see that within a HexWall versus a cross-flow on the very smallest unit that we have, we are better on efficiency all the way across the range, but we are a little bit higher on pressure drop, which you would expect from that longer dwell time inside a counterflow heat exchanger. So how does it compare? So we're a little bit smaller in height than you would get from a crossflow heat exchanger, but a little bit larger in depth. The width, for comparison reasons, is the same, but the efficiency is higher. The cost is 99 euros lower on the smaller model. If we go look a little bit further up the range, when we start to get towards a higher level of airflow, it starts to come into its own here at this point. So you can see that we have a higher level of efficiency, and we're also actually maintaining a slightly lower pressure drop on this unit. But one of the big advantages that you start to get now from when we get above HW1000 is that we really start to get a strong hold on making our physical air handling unit sizes smaller. So on the HexWall versus a Crossflow, we would be 346 millimeters less high and a little bit smaller in the depth by 180 millimeters with a higher efficiency and a lower cost. And as we start to move up through that range, that benefit actually only increases. So again, we can see on the screen, much higher efficiency, very similar pressure drop, but looking at those sizes again, so 330 millimeters shorter in height, 395 millimeters shorter in depth, 381 euros cheaper. Really starts to take hold. Above a HW1700, this is where we really start to move into new territory here. So you can see up from the screen that again we are much higher in efficiency all the way through the range with a very similar pressure drop as well, all the way through the range. But look at the savings. Oh, we skipped a few slides there. You'll have to forgive me for that. Let me get back to that. So on the HW1700, you can see that we're very much higher on efficiency and a very similar pressure drop all the way through the range. Cost-wise, 1,200 euros cheaper, and we're really starting to get much smaller in physical dimensions within the handling unit now as well. HW1800, again, much of the same, so higher levels of efficiency all the way across the range, very similar pressure drop, if not a little bit lower towards those higher ends. Lower in cost, lower in size, and again, quite a good saving in the footprint of your handling unit. When we start to get towards the HW2000, towards this top end of the range, this is where the savings really start to increase. So again, higher level of efficiency, very similar pressure drop all the way across the range, but look at the size differences now. So we're in the height difference of 700 millimeters lower in height, nearly a meter shorter for your air handling unit. Now that's, when we start to look at the cost, there's a 2,500 euro cost difference between this and a comparable cross-flow heat exchanger. But actually that's much bigger. So when you start to think that your air handling unit is going to be a meter shorter, there's also a cost in raw material that you're going to save from that sort of reduced footprint of the air handling unit. But most importantly, it's specifiable. So it will fit into a much smaller space than your competitor's unit would do. HW 2200, again, we're getting into these higher levels of airflow here, sort of around the 19,000 meters cubed an hour range, keeping a very high level of efficiency all the way across that range, whilst maintaining big advantages in terms of size and depth. And just look at the cost advantages here, 2,845 euros cheaper than an equivalent Crossflow heat exchanger of a similar size. And looking at the biggest unit that we have here, this is where we really see the biggest advantage that you would get in terms of a footprint when it comes to an air handling unit. So higher efficiency all the way across the range, a little bit higher in pressure drop, but that can be overcome with our new EC fan range. Again, look at the size difference here. So we are over a meter shorter now in length on your physical air handling unit size. Nearly a meter shorter in height, 2,700 euros cheaper in cost. It's a no-brainer, really. And when we start to look at how we can increase the physical presence or the amount of airflow that we can get through this unit now, one of the advantages that we have with this is that we can modularize this unit. So if 34,000 meters cubed an hour is not enough for you, you can put two of these side by side together and really increase that airflow. So up to 64,000 meters cubed an hour, whilst retaining 78% wet efficiency at a pressure drop of around 250 pascals. Now 250 pascals I know is quite high, but typically we would expect the selection points on this unit between around 120 pascals to around 220 pascals. So you can figure that we're going to be getting airflows above sort of 55,000 meters cubed an hour when we're at that level of airflow and efficiency. That's basically all. So if you've enjoyed this webinar, what I would suggest is that it would be really helpful to us if you could like and subscribe to the channel, like and follow us on Facebook, and if there are any questions, feel free to reach out via the YouTube channel to me personally or to any one of our key account managers across the world, and we will be only too glad to either come and visit you, show you through this product personally, handle any inquiries that you may have, and really get to help you to know and understand this new product, which we feel is disruptive technology for our industry. Thank you for your time, I appreciate it, and I look forward to seeing you on the next one.